Now we can go further. We have the information of the movement of our particle, the motion in one dimension, but it's only a plot. We can take that information and convert that plot into a GIF, a video. To do that, we have to include another library. This is called image.io. Now, the trick here is that a video is a collection of many pictures. If you put a picture over another picture and only let the user see every picture in a fraction of a second, you can have the vision of a movement, the perception of movement. So we are going to create many pictures, one per position. In this case, 11 positions, so 11 pictures. And then we are going to combine them together to form a small video. So we are going to include all these except the last instruction in the for cycle. This is because in every cycle of this for, we need to obtain a plot, and from that plot a file. So step by step, first we need to include all this information here, and we are going to save every plot using this command, plt.savefig. So we need a different name for every figure. So we're going to add a string variable here, and this string will be the number of the cycle in this for. In this case, we are going to use the item variable. Okay, and this is an integer, but we need a string because we need to put that information inside this function. So we are going to use the casting again and convert this integer in a string. We are going to add to this in a string the word JPG. This is the extension for a JPG file, and here we are going to write a string. So in every cycle, the name of the figure will be, for example, 0.jpg or 1.jpg, 2.jpg, etc. Okay, so we are going to save the program and run it to test that. Again, with the same initial height 5, the same initial velocity 10. Okay, and we are going to check in the desktop that we have 11 figures from 0 to 10. Let's going to open the first one. In the first figure, we can find the particle in the first part of the trajectory, and if you pass every figure, you can see how there are more points in the plot. If you pass them fast, you can see it appears like a video. So now we have all the figures here. We can return to the terminal and the notepad, and here, for creating the GIF video, the first thing is create a list. This list will contain the figures, all the plots, and we are going to use the for again. In this case, I am not going to use the item variable. I'm going to choose for example, I in range 11 again, because there are 11 figures, and all the data we're going to use is the name of every figure in the desktop directory in my computer. So in this case, I'm going to use the library image.io that I am reading the image, and here we are going to include the path or the desktop, my desktop in this case. Users, these users, okay. Okay, and again we need to include every file. Every file has a different name. We know that the extension of all the files is JPG, but between this part and this part we have to include the number of the figure. So I'm going to use the plus connector here, and we're going to use the casting again to convert this item, in this case I, this integer, into string. So in the first cycle, when I is 0, the first image will be 0.jpg. In the second cycle will be 1.jpg, and so on. And every image will be added or append to the last one. That's why we use this part of the library image. Okay. Sorry, this function apply to the list image. Okay. And finally, out of the for cycle, we're going to write this this function of the library image.io is mWrite. You have to specify here first the name of the video, in this case motion 1d.gif. Second, the list with the image, so image. Third, the format of your video, in this case will be .gif, the extension. And finally, the frames per second of your video. We can select something like 2, for example. Save the program and run it again with the same initial data, 5, 10. Okay. Oh, we have here a problem. Say image is not defined. Okay, this is because we define images with S, so we have to put it here with S. Oh no, sorry, that's not the problem. The problem is that this is from the library image.io. I put here a dot, sorry. Again, save the program and run it. We can use the same data, initial data, and here nothing happens, but you can check your directory. And here with the 11 figures you can find a video called Motion 1D. You can see it's a GIF. So we have our first really simple simulation of the motion of a particle in 1 dimension.